Physics, Part 28. As with the micrometer screw gauge, the vernier caliper should be checked for a systematic zero error before taking a reading. There can be few examples. Example number 1. Figure shows the scale of a micrometer screw gauge when the zero error is being checked, and figure of the scale when the gauge is tightened on an object. What is the length of the object? From the figure, the zero error is plus 0.12 mm. The reading in the figure is 2.10 B and 15.62 mm. The length of the object is thus 15.62 minus 0.12 mm, which is equal to 15.50 mm. The figure shows the scale of the vernier caliper. What is the reading? The zero of the vernier scale is between 5.5 centimeter and 5.6 divisions of the fixed scale. There is coincide between the third graduation of the vernier scale and one graduation of the fixed scale. The reading is thus 5.53 centimeter or 55.3 mm. This is another figure. Now it's your turn. Figure show the scales of the micrometer screw gauge when the zero is being checked, and again when measuring the diameter of an object. What is the diameter? The choice of method, a summary of the range and the reading uncertainty of length measuring instrument is given in the table. Instrument is meter rule. Instrument is micrometer screw gauge. Instrument is vernier caliper. The range of the first one is 1 m. The second one is 50 millimeter. The third one is 100 millimeter. The reading uncertainty on the meter rule is 0.5 mm. On the micrometer screw gauge is 0.01 millimeter, and on the vernier caliper it is 0.1 meter. There are notes for meter rule, check zero calibration errors. Notes for micrometer screw gauge, check zero error. And notes for vernier caliper, versatile inside the outside diameter depth. In deciding which instrument to use in a particular experiment, you should consider first of all the nature of the length measurement you have to make. For example, if you need to find the diameter of steel sphere, the screw gauge and the caliper techniques are obvious candidates. You should then consider whether you need the great accuracy of the micrometer in a particular experiment, and the uncertainty of the diameter of the sphere may be the dominant uncertainty. And in such a case, the fact that the accuracy available with the screw gauge is 10 times for vernier caliper, it will sway the argument in an experiment with many lost some time. You should also think about the resources of your laboratory. Is it sensible to use that maybe one of the only small numbers of available screw gauges when they may also be in demand by other students for other experiments? Sometimes in design questions you are asked to think about the cost of setting up an experiment. We have mentioned the difference of cost of a steel meter rule compared with the wooden plastic rules. It would be foolish economics to supply a steel rule for each member of the student, when it would be perfectly adequate to provide each of them with a wooden rule and have one steel rule available in the laboratory for calibration purposes. Application measurements of the pressure difference. A difference in gas pressure may be measured by comparing the height of liquid in two arms of U-tube. Figure shows U-tube connected container of gas. The pressure above is liquid in tube A. Atmospheric pressure is P atm. The pressure above the liquid in tube B, and hence the pressure of gas in the container, is P. The relation between the pressure is P is equal to P atm plus H Pg.